the general idea about how reinforcement learning operates is it has some kind of decision process. And we've already seen the decision process in the banner ad example. In this case, you have a website, which is your agent, something that can take actions. And this website repeatedly observes users that browse particular pages and can take an action. In this case, its action is to pick a banner and display it when the page renders. Finally, the agent gets a feedback whenever it shows an action to a user. The feedback in this case is a binary one. Either a user clicks or he doesn't. Now, of course, there's a number of similar problems. For example, you can replace banner ad placement with movie recommendations, for example, or you could even consider a problem of medical treatment. In this case, you have a patient that goes to a doctor, and the doctor is your agent. And your agent observes the symptoms of a patient to apply a treatment to him, and then he gets a feedback on how well did the patient feel himself after the treatment was applied, or whether he survived or not. Now let's consider this kind of practice problem. Let's say that you have an online shop, and in this online shop you're selling not movies, but let's say you're selling books. And you have a user base that's mostly authorized, so they have some personal data entered about them. And what you want to do is you want to sell them as much books as possible, and you want them to be satisfied with the books they buy. So basically you want to develop a system that recommends books to your users. So in this case, if you're trying to optimize your money and your users' happiness, how would you define the observation that your agent gets? What would you include there? What kind of actions your agent can take? And finally, what kind of feedback will he receive, and what kind of thing you want to optimize there? So of course, this is more or less obvious, but there are a lot of possible choices that are all correct. For example, you can define user features in great many ways. In general, you want to include here the features, the interest the user has, his age, his gender, maybe some kind of previous books he read and whether he liked them or not. And you also want to include any other information, like maybe his social network account if you have access to one. For actions, you now have books, and each action basically corresponds to trying to recommend a particular book to your customer whenever he visits your site. And obviously, your feedback is whether a user liked this book, or maybe how much revenue did you get from it, depending on your greed for money. So this particular problem is usually referred to as the multi-armed bandit problem. The name originates from gambling. You can consider yourself not trying to assign the optimal banner to each user, but gambling in a casino. And in this case, showing each banner is like pulling the lever of a slot machine. In this case, you want to find the slot machine which brings you the highest reward, or find the strategy, the banner which gives you the highest probability of user clicking and the banner provider paying you money. The same comes about recommendations, but instead of showing banners to get money explicitly, you can recommend users some kind of movie so that he watches them and becomes happy, and the overall happiness of humanity grows higher. And of course, this problem should not be viewed explicitly as the gambling problem, because in a casino, you are more or less certain from the offset that every slot machine is stacked against you. So please don't try reinforcement learning there. Now, the only issue here is that this formulation is incomplete for many cases. Remember the clickbait problem. So if you show users some kind of banners that are explicitly designed to be clicked often, but that leave users dissatisfied after he has clicked on those banners, you'll probably see high click-through rates initially, but then you'll just lose all your user base because they're frustrated by your advertisement campaign. So there's one missing link here, and it's about how your agent can affect the environment that supplies him with observations. In case of online advertisement, you have this user base, denoted as this Earth planet here, and whenever you take a particular action, you may affect your user base by either making some kind of user into your fan and seeing him more often, or basically scaring him off with some aggressive advertisement and basically losing this user and having less revenue because of that.